Okay, so today's lesson is on graphing polynomials and lots of review information to go through. Remember that if you have a polynomial and everything is multiplied out, so you see every single term, you want to make sure you're in descending order because the leading term, the term that has the highest exponent, has the greatest influence on the end behavior of the graph, and we want to graph polynomials today, so we need to know that. Also, because when you put 0 in for all the x's, all the terms go away. The constant term is the y-intercept. So if it's multiplied out, you can see the constant, you can see the leading term. Problem is, most of the polynomials I'm going to give you are going to be in factored form, so I'll have to teach you how to get the leading term and the y-intercept quickly. Okay. Reminder that the degree of the polynomial determines the shape of the end behavior. So I'm going to go through this quickly. If it's odd degree and the a is positive like this, 3x to the fifth, remember that's an increasing function because a is positive, and odd degree is opposite. So this is going to be down up end behavior like this. If it's odd degree and a is negative, it's going to flip that up and make it a decreasing graph. So that's going to start up and go down like that. If it's an even degree, remember it's the same. If a is positive, it'll be up, up, and if it's even degree and a is negative, it's going to flip and be down, down. Then we're going to be able to find the y-intercept, the zeros, and their multiplicity. Remember the zeros, you have to remember that zeros are x-intercepts. They're also known as roots, and if you know the factor, then you can find the 0 easily. So if x minus c is a factor, if you set the factor equal to 0, you find out that the 0 is x equals c. So for this one you have, sorry about that, for this one you have negative 5 times x minus 3 times x plus 4 times 2x minus 1. Now negative 5 is a constant, it is not a factor, it doesn't have an x. So it's just a constant, but x minus 3 is a factor, and so it would give you the 0 of 3. X plus 4 is a factor, and it would give you a 0 of negative 4. Because if I set each of those equal to 0, that's what x equals. 2x minus 1, if I set that equal to 0, that's going to be 2x equals 1 divided by 2, and x is 1/2. So remember, if you have a number in front of the x, the 0 is going to be the opposite, positive 1 divided by that 2. But you can do the work if you need to. Okay. So next, sometimes the zeros have multiplicity. Okay, so the multiplicity tells you the behavior at the x-axis. So if you have a 0 and the multiplicity is 1, like if you had x minus 3 to the 1, then the 0 would be 3, and it would be multiplicity 1, and if it's multiplicity 1, it's going to go straight through that 0. Okay, if your m is odd, like if you had a factor x plus 4 to the third power, then negative 4 would be your 0, but it would have a multiplicity of 3. And what's going to happen at that 0, because of the odd multiplicity, is it's going to be a bend. So if you start out below, it'll be an upside down U and then turn into a right side up U. If you start above at that 0, it'll be a U and then an upside down U. And you have to practice getting good at doing bends. And then if m is even, like x minus 5 squared, then the 0 would be 5, but the multiplicity would be 2. And if the multiplicity is even at that 0, it's going to bounce right at that 0 on the x-axis. Okay, so this example here, f of x equals negative 1/4 times x minus 3 times x plus 2 quantity squared. Now this is factored form, it's not multiplied out. So I'm going to show you how to find the y-intercept and the leading term. Let's do the y-intercept first. Remember, y-intercept universally, y-intercept you find when x is 0, because the y-intercept is on the y-axis, and that's when x is 0. So I'll just plug 0 in for x, and that would give me negative 1/4 times 0 minus 3 times 0 plus 2, quantity squared. And if you do not want to get it wrong, you can just plug that in the calculator. So that would be parentheses negative 1/4, parentheses 0 minus 3, parentheses 0 plus 2 squared. And you get 3. So when x is 0, y is 3. That's your y-intercept. Okay. To find your leading term, now the leading term is easy to find when it's all multiplied out. Now I don't want to have to multiply all that out, and I don't need to. All I need to do is make sure that these factors here are in descending order, and we'll do an example where they're not, because all you have to do to find the leading term is take the constant, and then the leading term of this factor is x, and it has multiplicity of 1. And the leading term of this factor is x, and it has multiplicity of 2. And then if you multiply those things together, that's going to give you your leading term. Okay, so negative 1/4 times x to the 1 times x to the 2 is negative 1/4 x cubed. That is your leading term. You found the leading term without having to multiply that whole thing out. Okay. Now that you have the leading term, you can look at it and say, okay, the degree is 3. And also a is negative. So you have to go back and memorize, look at the other side of the page if you need to. If you have an odd degree, remember it's opposite. If it's a is negative, it's a decreasing function. So this behavior is going to be up, down. Okay, that means you're going to start somewhere up here and end somewhere down here. Alright, now let's look at the zeros. We already have the y-intercept. So the zeros, I'll write a little table. Okay, so negative 1/4 doesn't give me a 0. Negative 1/4 doesn't have an x with it. It's a constant. But x minus 3 gives you the 0 of 3, and it has a multiplicity of 1. X plus 2 quantity squared gives you a 0 of negative 2, and it has a multiplicity of 2. Okay, so at this 3, the multiplicity 1 means you're going to go straight through. And at this negative 2, the multiplicity of 2 means you're going to have to bounce it. Okay. Alright, so now let's plot the points. We have 0, 3. Alright, and then we have a 0 at x equals 3, x-intercept, and an x-intercept at negative 2. And you can write yourself little notes if you need to. I'm going to put m equals 1 and m equals 2. And see, I'm going to start here. So you kind of have to plan ahead. The first thing that you're going to hit is this 0 here. And then the next thing you're going to need to hit is this y-intercept. Okay, so I need to bounce it right here because multiplicity 2. So I'm going to start here. Not way out here, maybe here. Bounce it. Then I have to come through that y-intercept. That doesn't have to be a maximum. I don't care where the maximum is, and I'm going to turn it around in time to smoothly go through that second 0. So that's example 1 there. Okay, so let's do another example. This time we have a negative 2 constant. We have an x plus 3 cubed and a 2x plus 1 squared. So the leading term, you're going to take the negative 2, and then this leading term x, and it's being cubed, and this leading term here, 2x quantity, and it's being squared. Okay, so what's going on there is negative 2x cubed, and then you have to do PEMDAS. So before you can multiply negative 2 times 2, before you multiply, you have to do the exponent. So 2x quantity squared is really 4x squared because you have to square the 2 and square the x. So the leading term is negative 8 and then x to the 5th, because when you're multiplying x base x to the 3rd, that means x times x times x times x times x. So you add the exponents when you're multiplying the same base. Okay, so the leading term is negative 8x to the fifth. That means the degree is 5. Since a is negative 8, that's negative, so that's going to be up, down again. The y-intercept, remember you put 0 everywhere you see an x, so f of 0 is negative 2 times 0 plus 3 is 3 cubed times 0 plus 1 squared. So 3 cubed isn't 9. Negative 2 times 3 cubed, that's 27, times 1 squared, negative 54. So your y-intercept is 0, negative 54. And then the zeros, we'll do a little table, and the multiplicities, and the behavior. Okay, so the zeros come from the factors, the x minuses. X plus 3 equals 0 gives you a 0 of negative 3. Multiplicity is 3, so at that 0 you're going to have to bend. You're going to have to practice this. Alright, 2x plus 1 equals 0 gives you negative 1/2 as a 0. And it has multiplicity 2, so that's going to be a bounce. Okay, and then we have the y-intercept. Okay, so let's graph. And then we run into this issue. A lot of times our y-intercept is way far away from the x-axis, so we don't want to count by ones all the time. If I count by 5s, I don't think I'm going to quite make it, so I'm going to count by 10s. So this is negative 10, that's negative 20, negative 30, negative 40, negative 50, negative 60. But I'm going to keep counting by ones for the x-axis. So I have to label my axes when I count by something other than ones. Alright, so my y-intercept is negative 54. So that would be here. And then I have a 0 at negative 3. And it's going to bend because multiplicity is 3, and I have a 0 at negative 1/2, and it's going to bounce because the multiplicity is 2. And the end behavior is up, down. So I have to think through this. I'm going to have to bend it through here, and then the next thing I've got to do before I hit that y-intercept is come up and bounce it here. So it's going to be pretty steep to get from here to here. Okay, so I'm going to start up here and I'm going to bend. I was going to start over here, but it's all a steep graph, so I'm going to get pretty close to it. And I'm going to, that's a right side up U and then an upside down U. And then I have to turn around and do a bounce and then go straight through that. And I end up down. Sometimes people forget about the multiplicities or something, and to make it work, they'll go through the x-axis an extra time. You can't go through the x-axis but here and here. Can't make it work by going through the x-axis again. Okay, so 3 more examples to go, and each one has something that you might need me to say. So this first one, what do you do with the negative? Well, this is an easy solution. You just make it a negative 1. So the leading term is negative 1 times x times x times x. Pull it from the leading term inside each factor. So that's negative 1x cubed. So that's an odd degree with a negative a value. Again, that's going to be up, down. Okay, the y-intercept comes from putting 0 everywhere you see an x. So you have negative 1. I'm going to do this in my head. 0 minus 5 is a negative 5. And then 0 minus 4 is a negative 4. And then 0 plus 1 is a positive 1. So a negative 1 times a negative 5 times a negative 4 is a negative 20. So the y-intercept is 0, negative 20. The zeros, and their multiplicity is all going to be 1. But the zeros, x minus 5's factor gives me a 0 of 5. X minus 4 factor gives me a 0 of 4. x plus 1 factor gives me a 0 of negative 1. So I'm going to plot those zeros, negative 1, 4, 5, and I'm going to plot that y-intercept 0, negative 20. I count by ones, negative 2, let's do 5s, negative 5, negative 10, negative 15, negative 20. So I'm counting by something different, so I have to label that. Alright. Now, the end behavior is up, down, so I'm going to start up here and end down here, and everything's straight through. So I've got to hit this 0, and then next I'd have to get that y-intercept. So I don't want to start way over here because I don't want any curvature. So I'm going to go straight through, straight through, straight through, and try to make my polynomial as smooth as possible. Alright, next example that you might want to see is just a very common error. I will tell you this x, anytime the x shows up, you know, it doesn't look like this and it throws people off, but you can make x look like x minus c if you just make it x minus 0. So this is a factor. Okay. The other thing that's weird here is this y-intercept is going to be awfully boring, because when I put 0 in for this x right here, then it just kind of makes all this other stuff not important, because you end up with 0 times all of that, so your y-intercept is 0, 0. So if you have a 0 of just a factor of x, your y-intercept is going to be really boring, 0, 0. Your zeros for this one, people forget about this 0 right here. X is the factor, and it gives you a 0 of 0, and it has multiplicity 1. Then we have another 0 at 2, and it has multiplicity 3, and then we have another 0 at negative 3, and it has a multiplicity of 2. Okay, so there's going to be straight through right here, it's going to be a bend here, going to be a bounce here, and you have one less point to graph because your y-intercept is the same as that 0. So let's graph that. 0, 0 is both an x-intercept and a y-intercept. Then we got 2 and we got negative 3, and that's all we have. Alright, what is the leading term? That comes from negative 3 times x cubed times x squared. This negative 3 times that x cubed times that x squared. Understood exponent 1 there. So this is going to be leading term of negative 3x to the, add the exponents, 6. So this end behavior is going to be down, down, because you have an even degree and a negative a value. So I need to start here and end here. And let's mark this up. Negative 3, you're going to bounce. This is m equals 2. 0, you're going to go straight through because it's m equals 1. 2, you're going to bend. Okay, so I'll help you with that. I'll just put m equal 3. We're going to bend. Okay, so we're starting down here and we're going to bounce. Then I don't care where you turn around, and you're going to have to go straight through. And you have to make sure you have enough room to do a regular U and an upside down U. Okay, so come up with a plan before you do it. So you're going to start down here, you're going to bounce. And you're going to go straight through. Now I need to be pretty steep, so when I turn around, I have enough room to do a U and then an upside down U. And it needs to be clear where I'll take off. That's pretty clearly a bend. That's a straight through, and that's a bounce. And sure enough, you did. You ended up down, down. Alright, the last example I added because sometimes in the lab manual you get to 1 and the factors are not in descending order. They need to be in descending order, so I've added an extra example to give you some factors that are not in descending order, and if you don't put them in descending order, then you'll mess up. Okay, so first thing you want to do is run through and make sure that things are in descending order, and we don't have that. So I'm going to rewrite the negative 1/2. The factor x minus 3 is in descending order, But this factor 1 minus 2x is not. The x's have to be first. So when you reorder it, be careful. This minus 2x, that's a negative 2x. And the 1 is positive. So you make sure the minus goes with this 2x. And then 4 plus x is not in descending order. You got to turn that around. That's x plus 4, and that's quantity squared. So just be aware of that. You have to make sure you're in descending order. Okay, so now the leading term is negative 1/2 times this leading term x times this leading term negative 2x times that leading term x, and it's being squared. Okay, so that's x squared, and so everything else you can now multiply. Negative 1/2 times negative 2 is 1, and then you have x to the 1 times x to the 1 times x squared. So that's 1x to the 4th. Okay, so that's end behavior up, up. Okay, the y-intercept, you have to put 0 in for x, so that's negative 1/2. 0 minus 3 is negative 3. Negative 2 times 0 is 0, so then that leaves you with 1. And then 0 plus 4 is 4, but it's being squared. Okay, so let's see what you get there. So we have negative 1/2 times negative 3 times 1 times 4 squared. And we get 24. Okay, so your y-intercept is 0, 24. So we have the leading term. We know the end behavior, we have the y-intercept, and now let's do the zeros and their multiplicity. So this is a constant, not a 0. This x minus 3 is a factor, so the 0 is 3, multiplicity is 1. This negative 2x plus 1 is a factor. So if you solve it, set it equal to 0 and solve it, you get negative 2x equals negative 1, and then x equals positive 1/2. Multiplicity 1. And then x plus 4 has a 0 of negative 4, multiplicity 2. So we're going to go straight through these two, but bounce at these two, this one. And this one, you have 3, negative 4, and 1/2 as my zeros, and the y-intercept is 0, 24. So you have to figure out what you want to count by. So I'll count by 2s, 2, 4, 6, 8, 10. Let's count by 4s. 4, 8, 12, 16, 20, 24. So decide to count by 4s there. There's 0, 24. Let's count by 1s, or you could count by 1/2. I'll count by 1s. 1, 2, 3. 1 0 there. We got a 0 of a half, and then you have a 0 at negative 4. Alright, and the end behavior is up, up. So that means I'm going to have to start up here, and when I get to negative 4, I've got to bounce because the multiplicity is 2. And the next thing I have to get is this. Ooh, this is going to be tricky because you have the y-intercept here, then you got to turn around and get all the way down to this 1/2. At least it's straight through. So it's going to be very steep here. And then you're going to turn around and go straight through these. So I'm going to start up here and bounce. And that's too steep. It's not steep enough here, so let me redo this. Let's see if we can come a little steeper and then turn around. Just an effort. Polynomials are very smooth. They don't have V's. They're all kind of U-shaped. Okay, so I have my bounce here, and my y-intercept looks like a maximum, but it doesn't have to be. And I turned around and went straight through this 0 and straight through that 0. But I started up and I ended up. So I know I did it right. Practice the ones in the lab manual.